Hey, so we're going to cover generics in Python, and if you haven't seen them before or heard about this term before, I'm just going to explain a couple of things. Before I get started, a couple of notes on my setup. So I'm in VS Code. I have the Python extension installed as well, which comes with a thing called Pylance. Pylance is like a typing tool. I've got a couple of configuration changes also in my VS Code, which you can see here. This is one of the important ones, which is that it turns on type checking mode in VS Code. By default, it's set to off, which will kind of give you some information, but not tell you the same level of information that you'll see in the video. Okay, so let's have a look at generics in Python. So we're only using type annotations in Python. A good way to think of type annotations is like a comment. So if I annotate the variable a as a string, and then assign it to a value hello. Then if I hover over the letter A in VS Code, I can see that that is a literal hello. Then VS Code would know that I've got these methods available to me because it's a string, so I can do things like a.upper. If I try to do something that doesn't exist on there, for example, a.items, it's going to give me a warning because I've told Pylance to tell me when I'm doing something which doesn't exist on that type. It will give me that warning, but it will still run the code. So type annotations are almost like a code comment. They don't actually impact how the code runs. Then I'm going to get that error there to say that string object has no attribute items. So even though I've assigned that as a string, it doesn't matter. I can also annotate something as a string and actually just assign it to a number. Like that's still going to work as well. It's going to assign the variable, but that's going to fail because upper doesn't exist on a number. So if I run that code, then it will say int object has no attribute upper. So remember, annotations are annotations, they're comments on your code. So as an example, let's say we wanted to make a function that creates a copy of something. And it takes our value and it returns a copy of it. I'm just going to use the built-in deep copy function, which creates a copy of the object. So if I had a variable called name and I wanted to create a copy of that object, then I could run the copy of function with my name. Now, this is automatically annotated as a string in VS Code, but I can explicitly do that by saying it's a string. The challenge here is that copy of takes anything. So if I wanted to annotate this function, I could use any because it takes anything. I'm just going to import that there. And then the return type is also anything because it'll be the same return type of whatever was put in. So if I give it a string, then it should return a string. The problem is that the way this is annotated is it accepts anything and it returns anything. So it's not obvious that it will return the same type. So copy of name, that variable now has no proper annotation. It's been annotated as anything. But actually the return type should be the same as the input type. So this is where generics come in. So what you can do in Python and many other languages as well is you can basically create a type variable. So if you import TypeVar from the typing module, and then we're going to create a type variable. Convention is that these start with an uppercase T. That's convention. It's not a rule. So if I create a type variable called T, all we do is instantiate that, and then the first argument is the name, which you normally assign to be the same as the name of the variable. So instead of having any, I'm going to assign that to T. Now, that type, which is the input, is the same as the type, which is the return type. So therefore, I can say that if T is the input, that parameter, then the return type is also T. So that basically turns that type into a variable which is copied across in the annotation. What that means is that now copy of name it knows is a string. So in VS Code, in PyCharm, in any other typing checker like MyPy for example, it now knows that copy of name has been annotated as a string. So when I want to use that variable, I've got the string methods available to me. Now, as I said before, annotations are comments. How this actually runs once you run the code is can be completely different, but this is how it's been annotated. So that is essentially a generic. So we've got a type variable for our function, and we've said, okay, it takes type T and it returns the same type. Let's take this a bit further. So let's say you wanted to make a utility method that returns the first item in a list. And if there is no first item, so if the list is empty, then it returns a default value. So let me just remove this code. Okay. So we're going to call this first, and it takes our list of items, which would be a type list. In Python 3.9 and below, you have to use the uppercase L and import that from the typing module. And then we're going to have a second argument, which is the default value, which could be anything. And then the return value would be anything. So here, the list of something, so we'll be more specific in a second, will then return the default value if there is no item. So if the length of items is 0, return the default value. Otherwise, return items 0, which is the first item in the list. So if I had a collection of names, then the first name would be first on names. And then if there is no first value, then it returns the default value. So first name is any because it's been annotated that way. So what we can do with generics is we can actually say, okay, if it's a list of a specific type. So again, we're going to create a type variable. Convention is it starts with uppercase T. It doesn't have to, it could be anything. You can also be a bit more descriptive if you want to. So if you want to call it T value, then we're going to have another type variable. Now what we can do is we can say, okay, it's actually going to be a list of T value, and the default has to be the same type. So we're going to refer to T value again. So a list of that type, and then the return has to be the same as the type of the list. Therefore, the return type will also be T value. So if I have a list of strings, which is what this is, and I input a list of strings as the first argument, and therefore I need to have a string as the second argument. So if I put 1, 2, 3, 4, 5 as a second argument, it would say, no, you've given it a list of strings, but you've set the default value as an integer, which is invalid. It also knows now that first name, the return value is going to be a string. So if we had a list of numbers, then again, first number would be first with the numbers and then whatever that is. So that's now valid, so that it knows that the first item that it's going to return will be an int because it's either the first item in the list or it's the default value. So this is a generic. This is how we're basically using type variables to kind of copy information between parameters and the return type. So this doesn't just apply to functions, it also applies to classes. So let's look at a slightly more complicated example. we're going to have a new class called record, and this is going to have a constructor and a couple of attributes. So we're going to have a unique ID, which I'll make an integer just for now. We'll have a timestamp to say when the record was created. And what else do we have? We have a value as well. So that could be anything. So when our constructor then would assign the ID, and it would use a timestamp to work out the created time and then assign the value. So let's have just ID and value, and then created is going to be datetime.now, and self.id is ID. Now, because that is an int, then we can annotate that first variable as an int. So it says, okay, we take an int as the ID. The value, again, can be anything. So that's okay. Now, when we use this, so if we have a variable r and we create a record, and the value, let's say, is a string, then r.value has an annotation of any, because the way that I've described this class, value can be any. Now we've kind of lost the type information because the type that we had as the input now has been lost. So all that hard work you put into have types between your variables and your methods and your inputs kind of disappears, and you lose all of the kind of typing information. So what we can do is we can have a type variable. We'll just reuse this one because we're not using the old example. And we're going to have that annotated as t-value. Now it now says that has no meaning in this context, because it's saying, okay, well, where is t-value? How do I decide what t-value is? Now, one way we can decide that is in the constructor. We've got the input value, which is t-value. Okay, so the challenge we have here is, how do we know what t-value is? Because when it was just a function, that's pretty straightforward because you have the input and the output. But with a class, that type variable can be referred to in attributes, it can be referred to in methods. So what we do is we inherit from a type called generic, and then we have the type value inside that. Cool. Now, so record is now a generic, and therefore t-value will carry the same type as the initializer. So my typing tool now will know that I can input a value, and r is a record, and then in square brackets, the record type is string, because it knows that I've used a string as the second argument to the constructor. So happy is string. If we put a float in there instead, it would now know that r.value is a float, and it knows that r is a record of type float. So that type value then is carried across. This also means we can kind of be a bit cleverer with, let's say we have another function, another method in this class, and we have a new value to update it with. So let's say we want to have a special method that updates the existing value with a new one. That type should be the same as the existing type. So if we have a variable value, then r.value, that value should be a float because it knows that the input to the record type was a float. You can also be explicit when you annotate this. So you can say that this is a record of type float. Pylance will warn you if you annotate it like this and you've actually given different arguments. But it kind of infers what the type is based on the input if you don't explicitly set it. But we're going to explicitly set it here. So that's how we can have a type variable which carries across in the class. Now you're not limited to just one. So if we had both a key and a value, and a key could be different types, then we're going to have T key and T value. So the type of key is going to be defined up here, and then we specify T key, and we add another attribute which is T key. Now again, we've got the issue where it doesn't know what T key is, so we add that as the next argument to this. It doesn't really make sense to have value then key, so the order is important in terms of how the user understands what the type variables are. And this comes back to what I was saying before, where, okay, you can just call it T and, I don't know, T2. But if you say to the user, record is of type T and T2, it's not really obvious what T and T2 are. So naming them kind of becomes important, because it should be more obvious now that T key is the type of key and T value is the type of value. So if we have now a key value and key and value in the constructor, then we've got the ID and we've got the key, which can now be a string, and we've got the value, which is a float. Now this is invalid because it now takes two type arguments. So record is of the key type is string and the float type is the value. So again, it knows that if I put an integer in here or a float or something, it knows that it's expecting a string and not a number type. You can basically put constraints on this as well. So if you don't want to just allow any type, you can put a constraint in as the second argument. So T key, I could say, okay, well, this could be either, it could be an int, or it could be a UUID, which is a unique ID. So I can say, okay, the key can be an int or a unique ID, and I'm probably just going to remove the ID argument then. So we've got key and value now, and we're going to assign key to T key. This is a bit simpler. So now I've got a constraint that says that T key has to either be an int or UUID or something which inherits from those. Okay, let's strip our example right back and I'll show you one more thing, which is TypeVar tuple, otherwise known as Variadic Generics. This is introduced in Python 3.11. And let's say that our record has got a tuple of values. So it's got more than one value. Let's say we're using a record to then store things in a database, like a database row, or you're storing a CSV or something. So values is actually, there's the key and then there's a set of values. So values would therefore be a tuple, which we would import from typing. And we would take the values in our constructor. Now, what you can do in Python is you can have sort of like variadic parameters by doing asterisk and then the variable name. Sometimes you'll see that written as args, that's just convention, but we can have star values. Now that then can be a generic as well. So we're going to call this T values, and we're going to use TypeVar tuple instead of TypeVar, and we're going to refer to that by unpacking it in our constructor. So star T values is used to assign to values. Therefore, we can also be specific about the type. So our tuple type can be a tuple of T values. Well, that's the unpacked version of that. So that's a star T values. We then have to update our generic at the top to refer to that as a generic of key and star T values. So we've got our constructor, which takes a key and then one or many values. It stores those in a tuple. And so we can say self.key equals key and self.values equals values. Now, when we have the update method, we don't need to use key, but let's just do values. We can again have star values and star t values. Cool. So when we create an instance of record, then the key type, if we just use a number, so the record would be 1. Values, what should we chuck in then? We'll chuck in a string, I don't know, a float and an integer. So now the type of record 1 is a type int, which is the key, string, float, and int, because that's the type of the values. So when I try and run record1.update, it now expects 3 arguments, a string, a float, and an int. So if I provided the wrong types, if I provided an int, a float, a string, sorry, and another string, then that's going to tell me I've got the wrong types in my inputs. So it should be that's now valid. We can use that as well to extract the type information out of the values tuple. So if I had A, B, and C equals record1.values, then it knows that A is a string, B is a float, and C is an int. So thanks for watching the video. I've put some links in the description with the code examples I've shown you so far, some references on how I've got my VS Code set up, as well as a tutorial on getting VS Code set up with all these advanced features. If you like this video, please like and subscribe. Cheers.